How you doing, everybody? Randy Richard in the shop. Well, the Hemingway ball turner is complete, pretty much. Basically, it's done. This is, here's the drawings again. Oops, there we go. The cover one. And pretty much it came out the way I think they intended. I did do a few things, very minor things differently, but I tried to follow the plans the best of my ability. I think the plans are a little thin. They might have went into a little more detail. Would have probably helped a little bit. You have to interpret it your own way on some things. It is a little bit complicated project. And I'm just going to talk about a few things. This is the tool holders I made actually for my AXA tool post on my small lathe. So I'm just going to pop this off of here. And their design is made for a smaller lathe. This design, if you go by these dimensions and everything, this is really made for a AXA type style tool post, or that size of tool post and that size of lathe. So my Logan's an 11-inch lathe, and it worked just fine on there. A larger lathe, you're going to have a special tool post because this won't be long enough, or the body part here won't be long enough to reach out and things like that. So to clear a tool post. A few other things. The oil hole was supposed to be here in the center, and I guess it would drip on the shaft and get into your bearings. I think what I'm going to do is I'm going to drill small holes at each bearing itself. So there's 2 holes in the top. I think the design of their dovetail method here should have a gib. I think it would be better off with a gib in here, and it's adjustable. If you make this like I did with your tool mount here, so it's on the left side of your tool post towards your chuck, which that way you're closer to your chuck when you're turning your ball for stability and rigidness. This little screw, make sure it's on the other side. Make sure the tightening screw here is on the other side. Now, and that's what I would do with the gib. I think I'd have the gib probably on this side, and I'd have a locking screw or a tightening screw on this side. Or you could just have your gib on this side and just do all that with your gib and have it snugged and adjusted for tension. You're really not locking this in position. This is more of a tensioning device, so you maintain rigidity and so you can adjust this quickly. You want some friction there so you can adjust it and it just stays in place. So if you had your gib on the outside part instead of the chuck being right here, it'd be a lot easier to have that out here to adjust. And then you could have your nice tension adjustment, and this would have a little bit of tension to it. So I think that would be a better setup. What else here? You're only adjusting this a few thousandths at a time. People suggested a bunch of different things, and yeah, okay, so I used a reamer, and that kind of screwed me on my bore. Now, I think everybody should go and watch Adam Booth's channel about one of his recent videos about reamers. And I tell you, just listen to Adam. Reamers screw you right when you want to do a critical type thing. And I did what they suggested. That was one of their suggestions, was to ream it. So I did, and it screwed me. Personally, bore it. If you want it to be accurate, bore it. Works far better. That's my opinion. This shaft on here fits absolutely perfect. There is virtually no play at all. Their bearing system works really good with the bronze bushes and everything. So that works out great. You can make this solid block here, dovetail, instead of having these separate pieces, which is a whole lot of work, extra steps. Make this out of a solid block. You can make your whole body here out of a solid block to fit on your tool post if you wanted. This way you can move it between lathes, different lathes and stuff real easily. Making the slide block solid with the gib idea, I think would be a far better idea. Okay, then you made 2 tool holders. I did not try the concave tool holder yet, but I will. The tool grind is really quite important. Round piece is here, but you're cutting axially, rotating across the piece, so the piece is coming at the tool, the cutting action. So this here, this surface angle here on top, in the front, yeah, is very critical that you have, 7 degrees back rake there, so that chip cuts and breaks off and comes out. If it's just hitting up there too square, it's too much. Then on this corner, you're also cutting as you go across, so you got to have clearance in here, so you cut just at the cutting edge. So this took a little while to get this ground just right to work well and kind of produce a good finish. I could have put a little more radius on that cutting point there, but I didn't. But it still came out really nice. Still worked out well. I ground a bit too much into this, so this is really thin in here. You can see that. Yeah, because I probably took this to the grinder 10 times trying to work on the angles, but it still worked. Ball came out great. Making this ball for the handle, first ball I've ever made on a lathe. Actually, I can't ever remember even filing one. I've made some radiuses, but not make actual ball. That came out really nice. The whole project came out really nice. A few other things I ended up having to do. Of course, I made a mandrel to hold the ball, so I made it just like the end of the handle was, and I had to make I made a tap for that 1/4 inch 40 thread, which, yes, it gives you 25 thousandths per rev due to the pitch of the thread, and that's why there's 25 marks on your dial. The engraving, the diamond, using the diamond grave worked absolutely wonderful for this. I think I'm going to take this, some people suggested, oh, you should harden that, and I 100% agree. That's made out of drill rod, and so it'd be very easy to harden that feed screw. So I'll probably take that out and harden it so the hex will, last a lot longer. I'm also thinking of bluing it once get all the surfaces cleaned up. I did pick up some of the Birchwood Casey Super Blue, liquid gun blue. So I'm going to try that stuff out and blue the thing up after I get all the surfaces cleaned up and ground. If there's any other questions you have, I tried to make a real detailed video set of the build of this and some of the problems I came across. Like I said, my intention was to try to follow their plans. But thanks for watching, and I'll show it again when I get it all cleaned up and blued. But I do like it. I need to grind some tools. I'll get some more that 1/4 inch high-speed tool steel and make some better tools for it. But it does work, and actually I'm very impressed. It works well. So thanks again, you guys. Thanks for watching. I have the ball turner mounted on the lathe, and you can probably tell I did some turning on here. This is just a piece of 3/4 inch aluminum. Also, it took me a while to get the grind, the tool configuration grind angles to work well. Now this is you're cutting in a couple directions. You're cutting with the material coming at the tool and actually along the long axis of your work. So radially you're cutting and axially you're cutting at the same time. So you have to get your angles to do that. I'll show you what I got so far, and it's working pretty well on here. I want to make a ball for the handle of the ball turner here. So this is just a practice thing, and then I'm going to put in bronze or brass blank that I made up. This is the action of the tool. It rotates across the top of the tool, and setting it up, first you touch off on the top. You adjust the height of the tool to touch off on the top, whether you do it with a cross slide or in the tool holder. I did both. First I adjusted it, this here was flush with the end, and then I adjusted the tool holder, and because as you cut, you're adjusting your cut by the dovetail sliding part. So first I touched off on the top center line with the cross slide, then I rotated over to the 90-degree position and brought my carriage over, so I just touched on the end, and we are ready to cut that radius. Now I just kind of worked it on down, cutting like so in small increments, and I cut this nice round end. Do a couple cuts. So if I put my Allen wrench in the end of the tool holder, I can just rotate like so, adjust a couple thousandths, rotate again, a few more. So that's the action of the cutter. see what I'm doing out here. So I have my Allen wrench in the end. I have this snugged down, and I just in a few thousandths and give it a turn. They come back, a few in. There we go. Actually, that's a very nice surface finish. If you just kind of polished it a little bit, it'd be perfect. But it's very, very smooth. It all has to do with the grind on that high-speed tool bit, but that we'll work on. So let's put the brass blank in. And this is a piece of 7/8 brass. I drilled and threaded the end and then counterbored a little bit for the 5/16 shaft that's on the handle of the ball turner here. And I made a mandrel that is the same as the ball turner, so it's 1/4 inch 20 thread and a 5/16 portion here, so I can turn the ball all the way down. The length of this is approximately it's 7/8. It's just a tiny bit over, and the diameter is 7/8. So we're just going to put that in lathe, and we're going to set up and turn this to a ball. First thing we do is we adjust the height of the tool. Now I'm just going to do some of that with the tool holder here. I flush this up, and I'm going to just do this with the tool holder. Yeah, we're just almost touching there. Not close enough. This is just it's not that precision of a adjustment. Alright, now after being on the top, we've come over to the end, center up on the center, and touch off and lock our carriage. Then we back this off till we can clear the work. There we go. Because we're going to come in and just nip in that corner first, right there. And as we work our way in, we'll form the ball. Make sure we're not going to hit our chuck. And I think we got plenty of room. And you should come all the way around and have to do the other end. Now, you can't take a very deep cut at a time. You're just doing a few thousandths at a time. I turned it around until I just got rid of the center spot on the round. Now I would suggest turning your piece concentric first, after you're on your mandrel, then do this. But anyway, that came out just awesome. Very good finish, actually. Very good. A little polish and it'll be just fine. I think we'll leave it. And I turned all the way down to the mandrel in the back. So there's no shoulder. This is a shoulderless one. You know, sometimes people, I know, leave a shoulder or a stem on the ball, but here I turned it all the way down there to the mandrel, and there won't be any stem. Alright, let's get it off of there, I guess. Don't know how I'm going to do that. Be on there tight now. Anyway, it came out really, really nice. Just gotta get it off the mandrel. Okay, it really wasn't that tight, so I just held I held the ball in I wrapped a rag around this, held it in the vise, the ball, and it just came out with a pair of vice grips on, or channel locks on the mandrel. So you can see how the mandrel looks. There we go. Shoulderless ball. Now put it on the ball turner. Should go right on. Very appropriate to make the ball. You can see how it just blends right into the being shoulderless or stemless. The ball just goes right on with a slight counter bore, maybe 1/8 of an inch, and the shaft goes right in. Thank you guys. Thanks for watching and sticking with the project. It did come out very nice in my opinion, and it does work really quite well. It's taken me a little while to get the old ball turner done. Well, not get it done, but you know, get to the point where I can make a ball, I should say, and I got it done. I got a ball made, and the video for it, and all that. Been so busy with work, you know, it makes it kind of tough getting all this filming done and stuff. So anyway, we got it done. I did do some bluing, so I blued the body block here. This did not come out as good as I wanted it to. I don't know if it's the material or it's just you know, cold rolled bar stock. But these, and I did these two end pieces here for the hub here, for the handle. I mean, the rest of them, you know, they came out really pretty nice. Pretty happy with that. I just don't know why that piece. I might take that off and redo it again and really let it soak for like overnight. I let it soak for over an hour, but it still didn't quite take the blue as well as I thought it would. But anyway, the rest came out good. You'll see some pictures. I did surface grind this block and this block to clean them up so they're real nice. I don't know if I'll blue the head. I like, oh, maybe I got some blue on the head. Oh, I didn't notice that. It was sitting here. Anyway, I might not. We'll see how it goes. There's the ball I turned. Little brass ball, about 7/8 in diameter. Very, very happy with this. A few things, only one thing I did do different is I drilled 2 oil holes here and here. Now, The hole is really small, actually, going down into the oil, so, or down into the bearing, I should say. The holes I drilled here, actually down here, I used a small center drill, and then I used a very small, it was about 60 thousandths, hole down in the center there to reach down into the bearing, one on each end. I also blued this, and this didn't come out as good either. It's in the bar stock. I'll probably have to soak that one again too. It did take me a while to get the grind right on the tool bit. Now I got this really thin because I ground it several times to get the angles. The angle here, the work is coming at it in this direction, but when you're turning also, you're also cutting on this edge also. So getting these angles is really takes you a little bit to get them just right so they work well. Now I haven't hardened this yet, the screw, and I'm going to heat treat that. I just haven't done it yet. A couple things, if you want to use it on a bigger tool post, this here has to clear the tool post, the head, when it swings. So you could scooch it out, but then your handle will hit the tool post. So you either make this part longer, if you're going to use it on a larger, BXA or CXA tool post, you either make this longer, or you could always make this hub longer, so the handle's farther back. So you could keep it the same length here, but you don't want to make this longer so your handle clears the tool post. So those are two options you could do there. What else is there? I think that's about it. The bluing I used was this here, Birchwood Casey Super Blue, liquid gun blue. I think, it comes out okay for a quick bluing type thing. Rust bluing is my preferred method. It's very time consuming, but it comes out I think better, much nicer. It just takes more. It just takes longer to do. And I'm glad you all stuck with the project. And thank you for watching. Thank you for subscribing. I hit 10,000 the other day. I just amazed at that. But hopefully we'll have more projects like this. I really enjoy making tools, coming up with things like this, like the Rotary Broach I did, the project before this. So, hey guys, thanks. It's raining here, by the way. It's flooding here. It's pouring. It's just amazing. Now we live up on a slight hill. We won't have flooding problems here. It's just raining a lot and just controlling where the water flows. But in town, it's flooding, and the rivers are chock-a-block full, and they're worried about a couple bridges. But anyway, you guys, if you're interested in one of these, see the link I had in the description for Hemingway kits. Thanks a lot, you guys. Fun project.